Hey team, I'm Maddie. Welcome to Science Side Up, and today we are talking about the first law of thermodynamics. The first law of thermodynamics tells us that energy cannot be created or destroyed, or more specifically, the change in internal energy of a system equals the net heat transfer into the system minus the net work done by the system. Fundamentally, thermodynamics deals with turning heat energy into work. So think like an engine or things analogous to engines. So that longer statement I just said is sort of the engine equivalent of energy cannot be created or destroyed. And that is about as much as I can explain without needing calculus. I am really sorry. I tried to find a more simplistic way to dig into this topic, but if we're gonna get anything other than surface level, we've got to do some math. I will explain the math as simply as I can whenever we get to it, so that you'll at least understand what I'm doing, if maybe not exactly how I did it. Other thing, I currently filming Maddie have no idea how long this video is going to be. So future editing Maddie, she's gonna know how long this is. She's gonna break this up into 5-ish minute chunks because that's about as long as a normal adult human's attention span turns out. So this video is gonna have multiple parts, but at this moment, I don't know how many. With all of that in mind, let's jump into this. Mathematically, the first law of thermodynamics is this. Delta U equals Q minus W, where delta U represents the change in internal energy, Q is the net heat transfer into the system, and W is the work done by the system. So anytime I see a new equation, the first thing that I want to think through is what are the units of my terms? So all of these guys need to have the same units, otherwise we're trying to add apples to oranges and that doesn't work. So all of these guys have units of energy. That's going to be joules in the sort of standard SI system. Oh, you could think of it as ergs. But fundamentally, all of these terms represent energy. And since we know that energy can't be created or destroyed, what we're going to see is that if we say add some heat to the system, we're going to add heat energy. Whatever I added here has to go somewhere. It can either go to work or it can go to internal energy, but we need it to be balanced somewhere. The system we're going to use to understand this equation is going to be a pot of water on the stove. Here's my pot of water, and the first thing we do is put our pot on the stove, and then we're gonna turn the burner on and start adding heat. So notice that we're not creating energy, we're bringing in energy from the outside and dumping it into our system, where our system is the water in the pot. So we're adding heat, which means my Q value here is non-zero. We have some net heat transfer into the system. So let's go ahead and put a little positive sign there for our Q. So this heat, this energy that we're adding into the system can only go to two places. It can go to doing work, or it can go to the internal energy of the system. We could increase the internal energy of the system. Now let's all think back to like high school physics, where we learned that work is equal to force times displacement. So work is fundamentally related to physically moving things. If nothing is moving, then I am not doing work. And we're gonna see how that very simple concept gets applied here. So when you first turn on that burner, the water is still. So any heat that we're adding to the system is changing the internal energy of the system. We're increasing the temperature of the water. Temperature is one of the ways we think about internal energy. It's not the whole story, but it certainly is a big part of it. So at first, very specifically before the water begins to boil, all of my heat being transferred in goes to internal energy. The point at which this system starts doing work is when the water starts to boil. When the water starts to boil, we start to have physical motion inside our pot. The water down here gets hot, it rises. Once it gets to the surface, it cools and it falls back down. And we get these convective cells. That's a term we use in meteorology a whole lot. I hope I just didn't get blue chalk on my cheek. And now some of this heat being transferred in gets turned into work. So that means that not all of the heat is being turned into internal energy. Not all of the heat that I'm inputting goes to changing the temperature. Now, some of that energy is being used to make the water physically move. I don't have a good example of how to turn like boiling motion into like an engine, but we're gonna get to an engine here in a second. But this was the simplest example I could think of to understand this, the most basic form of the first law of thermodynamics.
Hey team, Editing Maddie here. We're gonna go ahead and let this be the break for part 1 of first law of thermodynamics. In the next few vids, we're getting into more of the specifics of the math and changing forms of this equation, getting it into the more commonly used forms of the equation. So be looking for the next video here in probably a couple days. All right, cool team, I'll see you guys later.